In this video, I am going to explain about third chapter, metals and non-metals. And so, first I am going to explain about the occurrence. Occurrence means availability, how the metals are found. So, metals are found in two states. First is native form and second is combined form. Native is also called as elemental state, and combined form, we'll see what is it. So first is native form. Native or elemental state. It is the state when the metals are found in the form of very fine particles. So when some metals are found in the form of fine particles along with sand or soil, sand and soil of the rivers. And which metals like silver and gold, they are found in elemental state. Why? Because these are least reactive. They are noble metals. They do not react as such. So this is one point. Now this is native. Now coming to combined state. So rest of the metals and all the metals rather. So all the metals when are found in association with other non-metals like oxygen, sulfur, phosphorus, etc. So this is the combined state, and it is called as ores, and they are called as ores and minerals. They are called as ores and minerals. Now we'll see what is an ore, what is a mineral. Now coming to very important part, ore. So they are defined as the form of metal or combined form of metal found in earth crust. Earth crust means in the mines, earth crust, and from which metal can be easily and economically extracted. No, means metals can be extracted from the combined form easily and in less cost, that is ore. So most of the metals forms ores. Example like EBS, Fe3O4, Fe2O3, this CaSO4, then NaCl, they all are the ores from which metal can be extracted by suitable method. Now we'll see about the minerals. Now minerals, they differ from the ores in only one point. that minerals have more amount of unwanted impurities like sand, soil as they are found in earth crust. So minerals have less amount of metal component. So they are combined form of metals. Just combined form of metals found in earth crust. This is it. Found in earth crust. Like CuFeS2. It is mineral of iron and it is ore, mineral of. Now coming to minerals. So minerals, they have excess amount of sand and soil. And so they are uneconomical. They are uneconomical to get, a metal from the mineral. So they are just combined form of metal found in earth crust. And see first example, CuFeS2. So it has much less copper. So mineral of copper. It has more iron. So ore of iron. This is for your explanation part. Nowadays techniques have been developed, and so from this copper is also extracted. This is iron copper pyrite. This is iron copper pyrite. And it is also called as fool's gold. Fool's gold means it gives an impression that it is gold. It has shining like that of gold. It is yellow in color just like gold, but it is basically ore of this iron. It has techniques have been developed to extract copper from it, and so this is very important point to know. Now other point is that we say very important, all the ores are minerals. But all the minerals are not ores. This is a very important point to note. The difference lies in the amount of the unwanted impurities, and they are called as gangue. Unwanted impurity is called as gangue. See how? So coming to gangue. So unwanted impurities present in ores and minerals. So in case of ores, the gangue is less. In case of minerals, the gangue is more. So this is the basic difference. So they have when metal ores have soil, sand, pebbles, moisture. So they make the gangue uneconomical. Now we'll see about the properties of metals. So after basic introduction, I'm going to explain about the properties of metal. So first I'm going to explain about the physical properties. So first A, physical. So metals are solids except mercury. All metals are solid. So all metals are solids except Hg. Mercury is the only metal which is liquid at room temperature. So this is the first point. Metals are sonorous. Sonorous means they produce sound on hammering. You might have seen the school bell, the bell in temples. When we strike bell with a hammer, what happens? Or the bob starts ringing. Pleasant smell. So that is called as sonorous. Then metals are ductile in nature. Metals are ductile in nature means they can be drawn into wires. The property of metals due to which they can be drawn into wires, we can make them wires. It is called as ductility. The property is ductility and the metals are ductile. But all metals are not equally malleable or equally ductile or equally sonorous. The degree differs from metal to metal and it is the inherent property. Inherent means the inbuilt property of the metal. Next is metals are malleable. Malleable in nature. This malleable, so they can be beaten into sheets. You might have seen we have ornaments, we have utensils, we have different foils of aluminium, foils of silver, foils of gold, which we call them work. So this is the property of the metals due to which they can be beaten or hammered into sheets. So, but see, all the metals are neither equally malleable nor equally ductile. Ornaments are made up of silver, gold. Why? Because of this factor. They are most malleable, they are most ductile. Metal, we'll see later on. Now, metals are electropositive in nature. Electropositive means they have tendency to lose electrons. They have tendency to lose the electrons and gain positive charge. They gain positive charge, they form cations. But this formation of cations depends on the number of valence electrons. Like here, if we see sodium, so sodium loses an electron and there is formation of sodium ion. Why it is so? Because it has atomic number 10. Atomic number is 11, 2, 8 and 1. So 1 is the valency. Here atomic number is changed to 10 and the number of electrons lost by a metal depends on the number of electrons in the valence shell. Now coming to malleability and ductility, all metals are not equally malleable and non-ductile. See how. Gold is most ductile metal. Gold, this is a very important point. Gold, which most ductile metal. Most ductile metal, and from 1 gram gold approximately 2 kilometer long wire can be electron. This difference is due to the force of attraction between the atoms of the gold. So silver is very close to gold. So silver is the second most ductile and malleable metal. Same is the case with the malleability also. You might have seen on the streets there's a decoration by foils of silver and gold, which we call them work in Hindi. Work means very fine. Why it is so? Because they have very strong force of attraction between the atoms, and so they can be drawn into thin wires. And so you can imagine 1 gram, 2 kilometers. So this is about the some important properties of the metals. Now, other important property of the metal, metals are lustrous. Metals are lustrous in nature. Lustrous means they have shiny surface. They have luster. That is, they have shiny surface. They reflect the light, malleability, ductility, sonorous nature, electropositive character. This luster nature, it is not equal in all the metals. Some metals have less, some metals have more, and so this is there. Then coming to melting and boiling points. Melting and boiling points, they are quite high. They are having high melting and boiling points. Again, this is due to the very strong force of attraction. Strong force of attraction between the particles. And what is boiling now? The movement of the particles. So it is boiling and melting there. But no exception is there. Gallium. Gallium is exception. It melts on our palm. It melts on our palm. It means it has much less, melting point, just like butter. So this is about the metals. Now, coming quickly about the non-metals. So, non-metals, they are generally soft. They are generally soft, low melting substances, and they are found in all the 3 states, like solid, liquid, and gas. So this is there. Unlike metals, they have all the 3 states of matter, and so they are. This is one point, melting point. They are non-malleable. Non-malleable. They cannot be drawn into wires. Non-malleable, non-ductile. They are electronegative. They are electronegative in nature. Means they have tendency to gain the electrons and form the anion. Like we take the case of sulfur. Atomic number is 16. 2, 8 and 6. Sulfur gain 2 electrons and there is formation of sulfide ions. So atomic number becomes 18. 2, 8 and 8. So it is, children, the loss and gain of electrons. Metals exhibit reactivity by the loss of electrons. Non-metals by the gain of electrons. Metals lose electrons, acquire positive charge. Non-metals gain, acquire negative charge. Now coming to other point, which is just a striking point. Non-metals are brittle. They are brittle. Brittle in nature. Brittle means on hammering, they break into pieces. They break. They break into pieces on hammering. They break into pieces on hammering. When we hammer, just like this chalk. When we break, this is not metal. It is compound of metal. It is basically calcium hydroxide containing some gypsum to make it hard. So this is about the non-metals, but there are exceptions also, children. Like diamond. Diamond. It is an allotrope of carbon. Allotrope of carbon means the different forms of an element having same chemical properties, but physical properties are different. So diamond is having very high melting point. It is around 3,500 degrees Celsius. So this is about the physical properties of the metals and the non-metals.